Hello viewers, a good day to you all. I hope you are enjoying your day. Alright, today I have before us binomial expansion of brackets. This is a concept in general mathematics as well as further mathematics. I'll be looking at how this very simple concept in general mathematics translates to a similarly difficult question in further mathematics. Just follow me, you see that it's a very simple one. And when you get to the further mathematics and you see how very simple, how much more simple it is in the further mathematics aspect. So I have these two examples before us with which you are going to start, and then we'll proceed from there. Now, question number one. The first question we have before us is a plus b, both in bracket, raised to power 0. And of course, from our ideas of laws of indices, any number that is raised to power 0 will always be equals to 1, as long as that number itself is not equals to 0. So as we have a raised to power 0, it is expected our solution here is going to be what? 1. So that's the first solution that we have here. A plus b in bracket raised to power 0 is equals to 1. And we are done with that. For the second one, we have a plus b both in bracket now raised to power 1. When we have a plus b in bracket raised to power 1, any number raised to power 1 is itself, it does not change. So a plus b raised to power 1 is still the same thing as what? A plus b. It remains unchanged. Now, the next one we are going into, which is where little work will start to come in, that's where we are going to have a plus b both in bracket, and this time around they will be raised to power 2. And when we have a plus b in bracket raised to power 2, what is expected of us to have? That's going to be a plus b in the first bracket multiplying a plus b in the second bracket. We are going to have to expand this bracket, and that is where the idea of binomial expansion or expansion of brackets sets in. Now, when we have a plus b in bracket and another a plus b representing a plus b raised to power 2, so we will use the content of this bracket to multiply the contents of this bracket. So a multiplied by a, when we have a times a, that's going to be a squared. Then this a will also come and multiply b. First of all, we use it to multiply a square. We use it to multiply b. A multiplied by b, we are going to have it to be as ab. Arranging them in order which the letters of the alphabet comes in. Then we are done with the multiplication with a. We come with for the multiplication of b. B multiplied by a. B multiplied by a actually is going to give us ba. But then BA is the same thing as what? AB, if we want to arrange it, like I said earlier, in the order in which the letters of the alphabet come. So B multiplied by A is what? BA, which can be rewritten as AB also. So this is going to be what? AB also. And then finally B multiplied by B. B multiplied by B is going to be B square. So we have A square here at the end, and we have A square at the other end. In the middle, we have AB and AB. Since both of them are like terms, we are going to add them together. So we are going to be having a square plus ab plus ab, that's 2ab, meaning 1ab plus 1ab being their coefficient. 1 plus 1 is going to be 2, so 1ab plus 1ab is 2ab, and then plus what? B squared. So this is what we have. So this becomes a squared, as we have it there, plus 2ab, and then plus what? B squared. So this is what we have by the expansion, a plus b being squared. Now we have the third question, which is a plus b raised to power 3. And by a plus b cubed, or a plus b raised to power 3, what we mean is a plus b in the first bracket multiplying a plus b in the second bracket multiplying also a plus b in the third bracket. So this bracket multiplied by this will give us a plus b raised to power 3, which is being cubed. And the order to doing this, or the steps to doing this, is first of all to multiply these first two brackets. And when we multiply these first two brackets, we'll see that it's just exactly the same thing as what we had earlier, which is a plus b squared. And when we expand this, we'll be coming up with a squared plus 2ab then plus b squared in bracket as we have it here. What I have here is just what I've transferred down here, representing these first two brackets as we have it there. Now the next thing is to multiply by the content of the third bracket, which is a plus b. And then we are going to use this a square first of all to multiply the contents of this bracket. use 2ab also to multiply the content of the bracket, and finally use b squared to multiply the content of this bracket. So when we have a squared multiplied by a squared multiplied by what? A, according to the law of indices. When there is no power on it, it is assumed to be what? Power 1. And that's going to be what? A cubed. When you multiply and use the law of indices. So a squared multiplied by a is going to be a cubed. And then plus, the next one is a squared multiplied by b. A squared multiplied by b, that's going to be a squared b. A squared b. Now we're done with a squared multiplying this content. We go for 2ab. 2ab multiplied by a. What we have is 2ab multiplied by a. Of course, 2 is only appear once. That's going to be what? 2. And we have a here, we have another a here. So that's going to be what? A times a is going to be a squared. And then finally we have b here. So 2ab multiplied by a is going to be 2a squared b. The next is 2ab multiplied by b, and that's going to be 2ab squared. So we are done with 2ab. The next one, which is the final one, is a b squared multiplied by a. And when we have b squared multiplied by a, of course, this is b squared multiplied by a. That's actually b squared a. And remember, so that it can be in alphabetical order, we can rewrite it as a b squared. Nothing has changed, just the rearrangement. So b squared multiplied by a is what? A b squared. And then b squared multiplied by b, that's going to be b cubed. So the next thing to do now is to what? Simplify this long expression. First of all, we have a cubed, and there is no other value in a cubed. So a cubed is just going to come down as it was. Then we have a squared b. Is there any other one that is a squared b? Of course, we have it is a squared b. The coefficient of this is 1 plus 2a squared b. So 1 plus 2 is going to be 3. So that's going to be plus 3a squared b. And then plus ab squared, 2ab squared plus 1ab squared. That's also going to be 3ab squared. And then finally, b cubed. So when we expand the content of this bracket, this is the solution that is going to give to us. So I'm going to be writing down the solution here. And that's going to be a cubed plus 3a squared b, 3a squared b plus 3ab squared, 3ab squared, then finally plus b cubed, which is what we have here, b raised to power 3. So that's what we have for a plus b raised to power 3. The next one is to go for a plus b raised to power 4. And the list is going to go on and on. A plus b raised to power 4. So we have this. As before, a plus b raised to power 4 means a plus b, first bracket, a plus b, second bracket, a plus b, third bracket, and a plus b, fourth bracket. So we're going to be multiplying these 4 brackets together so that can give us a plus b raised to power 4. And like we did earlier on, the multiplication of these first 3, we already have that handy. And that is what? A cubed plus 3a squared b plus 3ab squared plus b cubed. Now all of these will be multiplying this bracket, which is a plus b. So this is going to be lengthy. It's going to be lengthy. So we'll be taking them. I'll try to make sure that my writing is small so that it can contain this place that we have. So a cubed, first of all, multiplied by a. That's going to be a to the 4th power, a raised to power 4, plus a cubed multiplied by b. That's going to be a cubed b. Then plus 3a squared b multiplied by a. That's going to be 3a cubed b. And 3a squared multiplied by b, that's going to be 3a squared b squared, because a squared goes with this, then b times b is also what? B squared. So we go for the next one now, which is plus 3ab squared multiplied by a. So first of all, we are going to have 3, then a times a, that's going to be a squared, and then we have what? B squared with it. That's the order. The next one is still this 3ab squared multiplied by b, and that's going to be 3ab cubed. Then we'll go for the final one, which is b cubed multiplied by a. So that's going to be ab cubed plus b cubed multiplied by b. That's going to be b to the fourth power, also known as b raised to power 4. B to the fourth power. So like we did in this concept also, all we need to do is to simplify them. Look for those ones that are like terms, bring them together, and those that are not like terms, write them as they were in this previous line. So the first one is a raised to power 4, no other value in a raised to power 4, so a raised to power 4 is on its own. A raised to power 3b, that is 1a cubed b, plus 3a cubed b, it follows in that order. No other one that is 3a cubed b or that is a cubed b, so that's going to be plus. Coefficient of this is 1, coefficient of this is 3, 1 plus 3 is going to be 4, so that's going to be 4a cubed b. Then plus the next one, 3a squared b squared plus 3a squared b squared. 3 plus 3 is going to be what? 6, and of course the variables beside 6 are going to be a squared b squared. So this is going to be a squared b squared. Plus the next one, we are done with these two. That's 3ab cubed plus ab cubed. That's 3 plus 1, that's going to be 4. So that's going to be 4ab cubed. And finally, the last man standing, that is plus b raised to power 4, which is the fourth power. So this is the solution for this expansion, a plus b raised to power 4. So I will be writing down the solution. So I'll be having a raised to power 4 plus 4a cubed b, which is the second one, plus 6a squared b squared, which is the third one, plus 4ab cubed, 4ab cubed, and then finally plus b to the fourth power, b raised to power 4. So these are the expansion for a plus b raised to power 0, a plus b raised to power 1, a plus b raised to power 2, a plus b raised to power 3, a plus b raised to power 4. And the list can go on and on. It can go to the 5th power raised to power 5, to the 6th power raised to power 6, to the 7th power raised to power 7, to the 8th power raised to power 8, to the 9th power raised to power 9, to the 10th power raised to power 10, and on and on and on and on. The list can go on. So what is the next step? These are the ones for probably your junior secondary school, maybe JSS 2, I think, and JSS 3. That's where you do this kind of expansion, JSS 2 and JSS 3. Now moving on to the aspect where it is being useful in further mathematics, or where it is being used in further mathematics. Now, what I'll be bringing out now are the coefficients of each of these terms here. The coefficient of each of these terms. So I'm going to target at the top here, coefficients. Coefficients. And what are coefficients? Coefficients are numbers standing beside letters. Coefficients are what? Numbers standing beside what? Letters. For example, what is the coefficient of A here? 1. The coefficient of B, 1. Coefficient of A here is also what? 1. Coefficient of B here is what? 1. Coefficient of A here is 1. Coefficient of B here is what? 1. What do we mean by that? The numbers that are standing beside these letters, they are 1, 1. Let's move on. Coefficient of a squared is 1. Now the coefficient of AB here is 2. Coefficient of AB is 2. Coefficient of B squared is 1. Coefficient of A cubed is 1. Coefficient of A squared B is 3. Coefficient of AB squared is also what? 3. Coefficient of A cubed B here is 4. Coefficient of A squared B squared is 6. Coefficient of AB cubed here is what? Is 4. So I'll be bringing out these coefficients one after the other. And you'll see that it's going to form a beautiful pattern. So let's see. Now, the first one is A plus B. And when both of them were raised to power 0, of course, we only have what? 1. We can see that there is no letter beside this one. When you have a number standing on its own without any letter beside it, such a number is called constant. Constant. As you know. So, A plus B raised to power 0 is 1. So, nothing with that. So, it's going to stand as 1 on its own. The next one now is the coefficient of the second expansion, which is what? A and B. Coefficient there is 1. Coefficient there is what? Is 1 also. So I'll be having them like this: 1, 1. This is single 1. These are double 1. Now the third one, we have A plus B raised to power 2. So I'll be writing that down also, and then their coefficient. A plus B raised to power 2. And what are the coefficients like? And their coefficients are 1, 2, 1. So we are going to have it like this: 1. The 2, I try to make it to be directly under this 1 so that it can form the pattern we are looking for. And then the third one will be just a little shift outside this first one: 1, 2, 1. And then the next coefficients to be listed out: A plus B raised to power 3. A plus B, both raised to power 3. And their coefficients are 1, 3, 3, 1. So we are going to have this as the first one, a little shift away from this. Then 3 will be directly under this one. This next 3 will be directly under this one. And then 1 will be away from this last one here. Then the coefficient of the fourth power, the fourth expansion, and their power and their coefficient: A plus B to the fourth power. What are the coefficients? Of course, the first one will always be what? 1. After that, we have 4. 4 will now come in between these two, directly under this one. That's going to be 4. The next one is going to be 6. 6 will come in between these two, directly under 2 also. Then afterwards, we have what? 4. Here also, we are going to have what? 4. And then finally, the coefficient of this is 1. Then a little shift away, 1. Now, if you look at this pattern that is coming up, is what we call what? A triangular pattern. If I'm going to draw the triangle around it, so it looks something like this. A triangular pattern. Now, this order can go on and on and on and on. Now, if you want to get out these coefficients like we have them here, they give you to the 10th power. Will you have to multiply these numbers by themselves in 10 different places? Of course not. You don't need to do that. There is a very simple trick with which we use to get them. Very simple. And that simple trick is what we'll be seeing now. You have to write the first one, which is 1. That has to stand on its own. The second one, which is what? 1, 1. If you like, you can call it 11. That has to stand on its own also. So we have 1, we have 1, 1. So the next one is this. The 1 will always move to the left of this. The beginning will always be 1 moving to the left of this. So how do we get the next one? 1 plus 1 will now be 2. No other number after this also. Then we bring down 1 directly. The next one, we have 1 here. 1 plus 2 will be 3. 2 plus 1 will be 3. Nothing again, so we'll bring down the 1 here. Then we have here also, before it nothing, so we'll bring down 1. 1 plus 3 will be 4. 3 plus 3 will be 6. 3 plus 1 will be 4. And then finally, we'll write down our 1. So tell me, what do you think A plus B, the coefficient of A plus B to the power 5, the fifth power, what's going to be their coefficient? Of course, we are going to start with 1, and that one will be a shift away from this first one. Then the next one is 1 plus 4, 5, 4 plus 6, 10 in between, 6 plus 4 also 10 in between, 4 plus 1, 5, nothing again, then we'll bring down that one also. So what's going to be the one to the sixth power? We are going to have 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, and then finally 1 also. Okay, so this list is going to go on and on and on and on. You can go to the 7th power, you can go to the 8th power, you can go to the 9th power, you can go to the 10th power, the 11th power, and it's still the same word order. It's still the same word order. And let's say we want to go for the 7th power. We're going to start with 1. 1 plus 6 is going to be 7. 6 plus 15 is going to be 21. 15 plus 20 is going to be 35. Then 20 plus 15 is also going to be what? 35. And then 15 plus 6 is going to be 21. 6 plus 1 is going to be what? 7. If not that there is no space again, it's supposed to be the final one. Pardon me for writing like that. Yeah, because I need to explain it. So there's supposed to be what? The final one. You can see where this final one is at the edge of my what? Of my board. So there is no space again for us to continue the expansion. But of course, you have gotten the gist behind what we call this triangle. So if I continue this order particularly, you see that the triangle extends. That straight line that is coming, and it goes like this. And this straight line also goes for what? The expansion of the what? The triangle. Now, when we're this triangular set of array of numbers, what is the name that is given to them in further mathematics, especially further mathematics SS2? They are called the Pascal's triangle. Pascal's triangle. So this is how the Pascal's triangle is being gotten. Triangular array of numbers. Gotten from what? Coefficient of the what? Expansion of binomial brackets. Expansion of what? Binomial brackets. And when we expand those binomial brackets, the coefficient listed out generates this particular one. And when we have the first two, of course, then other ones can be generated easily by just the addition of what? The two consecutive numbers as we have them here. The two consecutive numbers in the particular pattern. So I give to you Pascal triangle. In case you want to ask, what's the meaning of binomial? Binomial from the word bi. Bi means what? Two. Remember your bicycle. Bicycle or bicycle. Two cycles, two tire. Binomial, the what's it called? Combination of the zeros and the ones number. Those are the binomial numbers. So anything by, see by, you are talking about two. And what do you see here? There are two numbers raised to this. 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 And there are two numbers raised to this. So that's the concept of Pascal triangle. We are still going to proceed with this topic. So I'm going to tag this one binomial expansion of brackets 1. Then I'm going to be producing another video on binomial expansion 2, which is going to be what? A furthering of this particular concept. In the meantime, enjoy what I have for you, this first page and on the second page. So I say to you, peace out.